All right, welcome to another video here. In this video, we're going to be looking at how we use this idea of long division in order to factor a polynomial, because as you may remember in secondary math 2, we can factor polynomials that are of degree 2, which we called quadratics in secondary math 2. And in fact, if we notice at the very top here of our notes page, you'll notice that we have this mathematical expression, x squared minus x minus 6. And so if we were to factor that, I usually teach my students this idea called X games as a strategy in order to factor a quadratic or a polynomial of degree 2. And so the way that it works is what I usually do is I take our quadratic and I make the x in the middle a little bit bigger. And so the number on the right-hand side, this number, which is -6 right here, we're looking for what are two numbers that will multiply together to give us that -6. But we also have to make sure that those two numbers are going to add up together to give us the number on the left. Now, you notice that the number on the left here, that looks like there's just a negative sign there, right? But technically, there is a -1 that we're multiplying by that x in the beginning. And so technically, the number on the left is a -1. And so what I usually do is I look at, well, what will multiply to give us 6, right? So I usually start with 1. So I know that 1 times 6 will give us 6. 2 times 3, that'll also give us 6. And that's it, right? So I need to look at which of these pair of numbers here, which one of these will multiply to give us that 6, but will then add or subtract to give us the -1 on the left. And so we see that the only pair of numbers that will possibly do that are our 2 and our 3 here. And so I know that in order for me to get a -1, I'd have to take 2 and subtract 3 from it to get that. And so, factoring our x squared minus x minus 6, our factored form is going to be x plus 2, because remember down here it was a positive 2 in our subtraction of the 2 and the 3. And then we had a minus 3 there, so then we're going to have an x minus 3 next to it. And so this right here, this is our factored form, right? And so we have this x plus 2, x minus 3. And each of these things here, we call each of these a factor of our original polynomial. And you can see that with other numbers as well. But usually with whole numbers, the factors that we work with are usually just whole numbers. So for example, if we looked at our 6 over here, that -6, we know that 1 is a factor of 6, 6 is a factor of 6, 2 is a factor, 3 is a factor. And we know that we can multiply these together to get back our 6. And so just like with our numbers here, this x plus 2 and this x minus 3, multiplying them together will give us back our original polynomial there. So now what do we do though in cases where we have a polynomial that's bigger than a degree 2, right? So for example, we've looked at degree 3 and degree 4 polynomials. So how do we figure out how to find their factored form? Because if you remember in our graphing polynomials section, we looked at how we use the factored form in order to find our x-intercepts, right, in order to be able to sketch our rough graph. Well, it turns out we can use this idea of long division, just like you may remember in elementary school math, how you could take, for example, down here we have this example of 60 divided by 5. We could use this idea called long division in order for us to find what 60 divided by 5 is, right? And so, so we use this process of long division. So we usually set up our long division like this, right? We have this 5, and then we have our 60 on the other side, right? And so what we usually do in the long division is we first ask ourselves, well, how many times can 5 go into our 6? So we know it's going to be once, so then we're going to have a 5 down here. And so it's kind of like division, so let me just erase this part right here. So let me put -5 down below, right? And so we get 1 from that. And then we bring down our 0. And so we know that 5 can go into 10 twice. And so 5 times 2 gives us our 10. Subtract those, and it gives us 0, right? So it turns out that we can use a similar process in order to divide polynomials. And so in order to do that, though, we need to find or we need to be given a factor, right? So one of these up above, like we saw when we factored our x squared minus x minus 6. We need one of these factors in order to be able to do that. So let's look at an example down here below. So you'll see down below here we have this divide x cubed plus 6x squared minus 6 minus 30 by the factor x plus 5, right? So to do that, we're going to use a similar process to the long division up above. And so we're going to set up our division just like we did up above, where we have, if you notice down here, we have our x plus 5 ready to be divided into our x to the third plus 6x squared minus x minus 30, right? And so just similar to like we did in long division, we have to figure out, well, how many times will my x plus 5 go into this first part of my polynomial, which is x to the third plus 6x squared. And so to do that, what we're going to want to do is figure out, how can I make x plus 5 equal x to the third plus 6x squared? What do I need to do to change my x plus 5 so that it matches my x to the third plus 6x squared, right? And so I know that in order for me to make this x turn into my my x to the third here, I need to take x and multiply it by x squared, because this will give us x to the third, since this right here is just the same thing as x times x times x, right? Because x squared is just the same thing as saying take x and multiply it by itself twice. And so what we know is that we're going to have to multiply by an x squared throughout our polynomial here. And so you'll notice that if I then take that x squared and multiply it by the 5, I'll also get an x squared there. So coming down below here, let me just erase what I underlined here earlier. What we're going to do is we're going to get our x squared times our x, which gives us that x cubed. And then x squared times our 5 is going to give us our plus 5x squared. Now remember that I'm going to be subtracting all of this, just like I did up above here when we did the subtraction in the long division, or in the long division with our numbers. And so if I do that, this negative sign gets applied to everything inside those parentheses. So essentially this becomes negative x to the third plus, oops, sorry, not plus. See, I already made that mistake here. Not plus, it's going to be a minus 5x squared. And so knowing that, if I have a negative x to the third, that means I'm going to get 0 here when I add the positive x to the third and the negative x to the third. And then if I take the 6x squared and I subtract 5x squared from it, then I'm just going to be left with a positive x squared, right? And then, so now I have that here. So now what I'm going to do is I'm going to bring down the minus x from up above here. So I'm going to bring this down here, just like how we would usually bring down the 0, right? We brought down that 0 from up above. Okay, so then what I'm going to do is a similar thing, right? I'm going to try and see how I'm going to match, so let me get rid of this right here. How am I going to match, let me use red again. How am I going to match my x plus 5 with my now x squared minus x? Well, in order for me to get an x squared, I would need to take this x right here and multiply it by another x, so I get an x squared. So what that means is that up above here, I'm going to multiply by a positive x, right? Since I already have a positive x squared here, I'm going to multiply by an x, because when I put my x squared down here from multiplying my x's together, remember that eventually I'm going to subtract, so then those will cancel each other out, or they'll become 0 when you add them together, or subtract them. And then we're going to take the x and multiply it by the 5, so we get a plus 5x, right? And so then doing our math here, so remember this right here is going to become a negative x squared minus 5x, because remember this negative sign is going to get applied to the 5x as well. And so I'll end up with 0 when I take my x squared and subtract x squared from it. And then a negative x minus another 5x means that we're getting more negative, so I'm going to end up with a negative 6x, right? Okay, so then again, just like we did in the other long division, we're going to bring down our minus 30, and we're going to try and figure out how am I going to now match, So let me erase these right here. How am I now going to match up my x plus 5 with the negative 6x minus 30, right? So notice that here I already have an x over here, and here I already have an x as well. The only difference between this x right here and my negative 6x over here is that this one over here has the has a minus 6 in front of it, right? So what that means is that I'm going to need to take my x plus 5 and multiply by a negative 6. So let me go back to my blue. So that means I'm going to have to subtract off 6 here, okay? And that means that when I multiply them together, I'm going to get a negative 6. Now notice this time I have a minus 6x. Before we had like a positive x squared and a positive 3x. The reason I have a negative 6x here is because, remember, eventually I'm going to subtract these. And remember that a minus 6 that makes these end up being positive, right? And so so that's why I want to have it be a negative 6x to match up with that, because eventually it's going to become positive. And so then I know that if I take my negative 6 and multiply it by the 5, I get a negative 30. So notice I have exactly what I have up above, but because I'm going to end up subtracting these two, it's going to change all the signs to be positive so that they'll add up or subtract to 0, right? So now this over here, this becomes a positive 6x and a positive 30. So when I take the negative 6x and add it to the 6x, I get 0. And when I take the negative 30 and I add it or subtract it to the positive 30, it's going to become 0 as well. So I'm just left with just a regular old 0 at the end. And so what that means, let me use a different color here. What that means is that this right here is my reduced form by dividing my x plus 5 into the x to the third plus 6x squared minus x minus 30. And notice this is just exactly what we had up above, so then I can take this and factor it like we did up above. And so now I get a full factored form of, so we know that from up above, this is x plus 2 times x minus 3, right? And then I can't forget my x plus 5, because that's another factor since we were able to divide it evenly into our degree 3 polynomial, so then I have an x plus 5 on the end. And this right now, this is the factored form of the original polynomial we started with at x to the third plus 6x squared minus x minus 30, okay? So that's an example of long division there. So now let's take a look and see what happens though, because you might be asking yourself, well, what if I end up with a remainder? Because you might remember from elementary school or from previous times of using long division that sometimes you end up with a remainder, right? So an example is this one right here where we have the 63 divided by 5. So notice that just like up above with our 60, we know that 5 is going to go into 60 12 times, but then we have this 3 left over on the end. And so what we do is we take that 3 and we put it over the 5 that we were using to divide with earlier. So that's why you'll notice with our answer it's 12 and then 3 over 5, right? So a similar thing happens when we do long division with polynomials. So let me show you this example down here. So we'll do another example of long division here. And I'll go a little bit faster this time since you saw up above how we were able to do the long division, okay? So down here I have, so this is saying that we are dividing by x plus 4 into this 2x to the third power plus x squared minus 20x plus 20, right? So if I take the x plus 4 and divide it in, then what that means is that I need to make sure that my x plus 4 matches up with at least the beginning part, the 2x to the third, right? And so to do that, I'm going to need to make sure that I take my x and multiply it by a 2 times x to the second power, because this will result, if I multiply those together, in 2x to the third. Okay, so that means that I'm going to put 2x squared up above, and so I'm going to multiply everything together, so I have my 2x to the third, and then 4 times my 2x to the second power is going to become a plus 8x to the second power. And remember, I'm going to be subtracting those, so this becomes minus 2x to the third minus 8x squared. So combining that with what I have up above, I'm going to get 0 with my 2x to the third and my negative 2x to the third. And then my minus 8x squared and my x squared, this is going to result in negative 7x squared. Okay, so then same thing again. I'm now going to figure out how to make my x plus 4 match up now with this negative 7x squared. And so I'm going to take my x here, and in order for it to match up with my negative 7x squared, I need to multiply by a negative 7x, right? Because that will result in x times negative 7x. That will result in negative 7x squared. So that means I'm going to put a minus 7x up above. So then I get, oh, and we forgot to bring down our minus 20x, right? That's important. Okay, so then I multiply my negative 7x by my x to get the negative 7x squared. And then a negative 7x times my 4, that's going to give a negative 28x. Okay, and then remember that I'm going to be subtracting those from each other. And so, so I end up with a, so my negative sign here, it's going to change it into positive 7x squared and a positive 28x. So then this becomes 0 when I take the negative 7x squared and I combine it with the positive 7x squared. And my negative 20x combines with the positive 28x, so that I'm left with a plus 8x, right? Okay, so I'm going to bring down my final 20, so plus 20 here. And now we need to figure out how to match up our x plus 4 with our 8x there. And so we notice that the only difference between our 8x and our x is that we need to multiply our x by 8. So then on the end here, I'm going to put plus 8. And so then I'm going to get 8x. And then 8 times our 4 gives us a plus 32. And so remember, I'm going to subtract those. So that's going to become a negative 8x and a negative 32. So then my 8x and my negative 8x will become 0. And the 20 and the negative 32, when you combine those together, you're going to end up with a negative 12 on the end there. Okay, now notice that I don't have anything else left to bring down with the negative 12. And so this negative 12 is a remainder of our polynomial here. And so what that means is that for our final answer, as we just saw up above when we do long division with whole numbers, we're going to take our 2x squared minus 7x plus 8, and then we're going to add on our negative 12 over, remember the thing that we divided by, which is our x plus 4. And so this would be our final answer if we have a remainder, okay? So those are just some examples of things that you would see with long division, right? And so hopefully this video was helpful to see a couple of these examples of how you might use long division in order to factor down a polynomial. Now notice though that, so just one final word, notice that with this 2 times x to the second power minus 7x plus 8, we could try to factor this part right here, but because we have this remainder, it's not going to give us a nice factorization that we might be able to use to easily come up with our x-intercepts there that we'll have in our polynomials. So when I have you guys find, or in the future, usually what you would do is you would make sure that you have a situation where you can get a nice number out like we had up above in the first example, so that you can factor it really nicely here to get your x-intercepts. So again, hopefully this video was helpful, and I wish you the best with the homework and being able to be successful on the test.